Hi, everyone, and welcome to the Aircraft Certification Channel. I'm Clarissa Fedel, and together with Rafaela Caillaux, we create this space to share information about aircraft development and certification. So if you are passionate about aviation like us, subscribe to our channel and hit the bell to be aware every time that we upload a new video. And if you like our videos, give us a thumbs up. Today, I will be talking with Borges, a specialist in maintenance and safety. You love this video because you will learn why it's so important to maintain the aircraft properly. Welcome aboard and enjoy your journey. Hi, Israel. How are you?
Hello, Clarissa. How are you?
Thank you for being here with us.
Thanks for having me.
Before we start, can you do a quick introduction of yourself for our audience?
Oh, yeah, definitely. So my name is Borges. I've been working maintenance and safety for a couple of development programs, especially in the commercial regional aircraft segment. And so I hope I can talk a little bit about maintenance and how this expertise or this discipline as part of the certification aircraft is so important for the big impact it has on customers.
For sure. Thank you. Thank you for being here with us. So as we'll be talking about maintenance, I think the first question that comes in the mind is why we needed to perform maintenance on an aircraft.
Yeah, basically, so we designed the aircraft to comply with certain certification requirements and to achieve a certain reliability level, like in terms of safety, in terms of operation performance. And these things, like with the utilization of the aircraft, they degrade with time. And maintenance is necessary to actually restore it to what was initially designed. So conceptually, this is the intent of maintenance. And this can be achieved by doing what we say a corrective maintenance, like when something breaks, we can fix it, like as soon as the failure is detected, or by another approach, which is doing a preventative maintenance. So we do periodic inspections on the aircraft on specific systems and to check the integrity of the aircraft to anticipate problems like and prevent failures to have impacting the safety and the operation of the aircraft.
Yeah, you mentioned those two types of the maintenance, the corrective and the preventive maintenance. And I think that the corrective maintenance is very clear, that it's broken, need to be fixed. However, we have this concept that's the preventive, that we not necessarily needed to wait to be broken. And how, and then you define those maintenance periodic checks, periodic verification to try to avoid or anticipate which component will or which equipment will fail, and then try to restore it to the original condition, or keep monitoring it to do this replacement when necessary. But I think that what's really interesting to know is how you define. So what are the requirements to, okay, this one, I will not do any preventive maintenance. We wait it to break and then we fix. And for those ones, we will define some periodic checks and to keep monitoring and so on. So what, how are the requirements? How you define those things? How this maintenance plan definition works? The requirements for do that.
Right. So as you properly said, like we need to have a more systematic approach to define exactly what has to be checked. Like obviously, if you decide to check everything, like you're not going to fly the aircraft. Like keep only checking it. That's not intent. So with this intent, like to define a systematic approach to identify requirements, essential requirements to be checked, there's like methodologies that the aviation industry currently use to come up with these specific requirements, right? So the whole principle behind is like, if it's working, you don't need to fix, right? So, but you have to identify what are the key functions that need to be preserved. And for that, there is a methodology that's used. It's called MSG3, and we can explore a little bit more of that. But there's other methods like that is in the context of the safety assessment, like fault tree analysis, or also for the structure analysis, they have the damage tolerance assessments that also define requirements and other specific requirements that depending on the specification regulation that we can discuss a little bit more. But the most of the maintenance requirements are defined basically by the MSG3.
Okay, so basically you have some of these preventive requirement, maintenance requirements that comes from the safety analysis, as you mentioned, that's the FTA or the damage tolerance, and some come from this MSG3 methodology that I'm understanding that's broader than only safety, take account other situations like operation, cost, and so on. Right?
That's correct. That's correct.
Okay.
That's correct.
So can you briefly explain what's the MSG3?
Yes. So the MSG3, just to talk about the name itself, MSG3 stands for Maintenance Steering Group, which was the methodology got the name of the group of specialists that developed the methodology. So, and it is in the version 3, which is the version that's being used in the last years. So it's called the official name is the Operator Manufacturer Schedule Maintenance Development. And the document, the methodology can be found in it's currently published by the A4A, the Aircraft for America. It's an institution in North America. It's the former ATA, right, the Air Transport Association. So the methodology itself, it has 4 different approaches. Like there is one that deals with the system and power plant. Another one that deals with the structures of the aircraft. Another one that deals with zonal and electrical wire interconnection systems. And another one that focuses on the light and high intensity radiated field protections of the aircraft.
Can you explain what is this a little bit? How is this 4 approach? Give you some more details about that?
Absolutely. So I prepare a slide here just to summarize the methodology. So for the system and power plant, like you can see on the top here, so the aircraft is broken into different, like all the systems are classified in different parts, like and subsystems. Like for example, you have the fuel system of the aircraft. So this is broken in the fuel tank, vent, the fuel engine feed system, the APU feed system, the fuel tank indication. So there are multiple parts of the aircraft. So there are small parts which basically are a set of components that perform a particular function. So these subsystems or systems, as we call them maintenance significant type, right? And those systems then are there is an analysis that's done for each one of the systems where you identify the functions, the function failure and effect of that the loss of those functions can cause, and also what are the failure causes, like what are the types of failures of each one of the components of this particular system, and how they can lead directly to the loss of those functions. And so the next step of the methodology is to identify means to prevent these failures from happening, right? And there is a preset list of types of tasks. Let me go back here. And which starts with cheaper tasks, and like lubrication and servicing. And then you go through checks, like operational or visual inspection or checks. Then you go for inspections, that can be visual, can be detailed, or more like special detail inspections, and restorations where you remove a part and send to a shop, or the discard where you actually remove and throw away the part. So this is the selection process. So that's like all these tests are defined like with proper intervals, like to be done periodically. As for the structures analysis, like the aircraft is also broken down in, like, the structure parts are selected, like the different structure pieces, and the susceptibility to different types of damage is assessed by means of a rating system. So there is an assessment then for for fatigue damage, another one for accidental damage, like things that can harm the structure part, like external agents, and also the environmental damage, like things from the environment that actually can lead to things like corrosion. And based on these rating systems, there will be the definition of inspections to identify those damages, and the frequency of these tasks would be as frequent as how more susceptible these parts are to those damages. A third approach, which I kind of lump it in the same explanation here, like it's for the zonal and the lightning earth and the US. So the aircraft is broken down in areas, like it can be we call item of analysis, like, so areas of the aircraft, and also for the protections, like you put together in this same area, like all the protections for lightning earth. And each one of those items are analyzed for the importance of these components, the exposure to damages, and also the robustness of the component or the area. And also, it's like the assessment is done by means of a rating system, which we're going to follow the same principle. Like the task could be as more frequent, as more exposed the area is, or the less robust the protection is, to extend to extend the damage that can be from the environment. So, and the tasks that are defined, like, can be inspections, can be cleanings in this area. So this is like a summary of the methodology. Like there's a lot of details behind this, but it deserves a training by itself.
I'm already expecting you to come here again, just to talk about the methodology itself. But just a quick comment on that. I don't know if you agree with me. When you talk about the system in structures, the way that is analyzed, it looked like, for me, like the starting point looked like a FMEA. And of course, the output, you are more focused in maintenance, but it looks like similar to safety analysis, and the same for the zonal and earth and lightning, that would be more similar to the zonal analysis and the particular risk analysis, that are methodologies that we use, we apply during the safety assessment. Is my perception correct? And then if yes, what's the main difference between a safety assessment and the MSG3 methodology?
Yeah, there are also a lot of similarity, like the similarities between the two analyses, like but they have different objectives, right? So the main objective of the safety analysis to meet the specific requirements of reliability, and that have to be demonstrated by using fault trees. And you have a systematic identification of all the failure modes by means of the FMEA, and the proper assessment of severities. I think you have a section that explains all the details of the safety assessment. But there is a parallel, and actually, well, the analysis during the certification process is conducted by two different groups. Like there is an independence between the two groups, but they talk to each other through the process to be sure that their analyses are harmonized. So, but for example, the identification of the failure causes, they need to be harmonized with the failure modes that were identified in the FMEA, and also the classification of like whether the functional failures have like the impact, like on safety or operational. They have to be consistent with what the assumptions that were done on the FHA, the functional hazard analysis. Like MSG3 cannot call something that's safety if the safety analysis doesn't call this thing safety, and vice versa. So all these aspects are discussed in parallel by the different groups. But one of the things that MSG3 is very distinguished from the safety analysis, like when he analyzes the functional failures and lists the failure causes, like it's always if the failure leads directly to this functional failure, whereas the SSA also looks at combination of failures, like you have all default tree that actually modeled all these correlations. So this is one of the key differences. But the SSA identifies also certain requirements, like for latent failures, which are called, they have a specific name, like certification maintenance requirements. And MSG3 has its own tasks, like for hidden failures as well.
I think you mentioned something that is very important. That is the interface between the maintenance team and the safety team, so that they can cross-check and see if they are arriving the same conclusions. They're having the same conclusions, because if they are not, there's something wrong. Something are not being evaluated correctly, or something is being missing. So it's very important, is the interaction between the safety engineer and the maintenance, right?
That's correct. That's correct.
Okay, so very, very interesting that. You mentioned that besides the MSG3 methodology, there's any other methodology to do this kind of analysis, or no, that's the only thing that is known in the industry right now? Which other kind of analysis you can do?
Yeah, there are other, like MSG3 is what is a type of what they call the reliability centered maintenance. And there is SAE today has a standard that lists all these different types of RCMs. Like, so it's just for the record, like there is a SAE, automotive engineering, like it has the standard JA 1011, and there are other types of RCMs. MSG3 was one of those. But MSG3 is the one that's normally used and acknowledged by the commercial aviation industry. Like it actually is a methodology that's actively maintained. There is a group currently in the industry that maintains this methodology. They are constantly being updated. Like there is this group called the International, the Maintenance Program Industry Group that like gets all the different manufacturers and suppliers, that they always discussing subjects around the MSG3 methodology and doing the updates. And also the authorities have the International Maintenance Review Board Policy Board, which is also the group of authorities that analyzes all these updates on the methodology.
Israel, you mentioned that the MSG3 is the most accepted methodology for the certification authorities. So does it mean that there's a specific regulation that requires the maintenance analysis and the definition of maintenance tasks? Is that correct? So can you, what are those requirements, and if you can briefly explain them?
Basically, we have the main requirements is 25.15.29, which calls for what's called the instructions for continual worthiness. So there are many, all the manuals that are required to operate the aircraft. like they need to be provided as part of the certification process, which contain not only the list of scheduled maintenance requirements, but also all the other manuals, the aircraft maintenance manual, the illustrated part catalog, and so on. And these, this is actually the requirement that drives all these maintenance requirements. But obviously, there are other requirements that can also produce maintenance requirements, like the 25.1309, the 25.571 for damage tolerance, for fuel tank explosion, for UIs, or any other specific requirements for certain parts or components that require specific maintenance. So all those processes, they also produce maintenance requirements that they need to be captured in these instructions for continuous airworthiness. Okay. And for these, and for those requirements, there are also advisory material that actually propose processes on how to produce those requirements. And the most, the bigger ones are the AC 121.22, which talks about the maintenance review boards and process for using MSG3. And there is one particular one that deals with the requirements coming from the safety assessment, the AC 2519.
So you mentioned that you have two ACs, one about the MRB process and one about the CMCC. I want you to talk a little bit about those two processes, but in another opportunity. Now I want to just to finalize. You explain that after all these analyses, you probably document that for the certification authorities and also for the operators. So can you briefly describe what is which documentation are generated of all these analyses?
Yes, for the certification process, normally the MRB, these group of people, the results of the MSG3, they're capturing a document called the Maintenance Review Board Report. And this document is sent as part of the certification process to the authorities. But as I mentioned, like, there is other documents that are also producing those maintenance requirements. So there is a dedicated CMR report. There is one for the fuel system limitation. There's another one for the US. So all those reports, they're then captured, like the ones that are producing for certification, they are put together in a document called airworthiness limitation. Right? So so normally we have one that has the MRB information, and there is another one that has the requirements coming from certification. So they're the documents that are normally produced and approved by the authorities. But the customers itself, they receive all this information in a document called the maintenance planning document, MPD, some call it maintenance planning data. And this document lumps up all the requirements and also add other information that's necessary for the customer to do the planning, right? So there's labor hours for each one of those tasks, which access panels they need to be open on the aircraft, which are all the procedures that are necessary to be performed, like to be used when they do the planning of this craft and execute. So when the customers, they need to get this document, and also they have to prepare their own version of this document, and they have to submit to their local authorities to get the approval to operate.
We have this discussion mostly about the part 25, but there's similar activities that are done for the other airplanes like general aviation or rotorcraft, or even those new electric airplanes that are being built, or is under discussion with authorities.
Yeah, it's good you mentioned that. Actually, the MSG3 today, like, it has a second part, like the document is split in two documents, like the MSG3 methodology. And there is one part that's dedicated for rotorcraft, for helicopters, and so there are other things like for the newer craft, like for the vertical takeoff. I think they're currently acknowledging the existence of these new aircraft, but there's nothing defined yet. But I mean, there's a topic that's under discussion today in the methodology.
Okay, so Israel, I think that this is a topic that if we can stay talking all day long. if we can keep going. So I will stop here now. But before, so I want to thank you very much for your contribution and sharing your knowledge with us. But before we finish, I would like you to share with us your thoughts and recommendations for a successful design in terms of maintenance approach. So what the system engineers, structural engineers that are developing airplanes need to take into consideration when they are doing their preliminary analysis and also along the design.
Yeah, I think it's important the maintenance groups that do the MSU3, they always involved during the early phases of the design, like to ensure that the design, like because the design, the maintenance is it reflects the design. Like if you have a design that does not contain properly monitoring, like there'll be sometimes necessary to have tasks that could be prevented if you had proper monitor failures. Like if a failure happens, this would be reported to the crew. So, but this is only it's only possible to know those things if the maintenance groups are doing a parallel analysis while the design is being defined. So that's the most important aspect, and the customer is always involved since the early phases of the design.
Yeah, I think that you're totally right. That's all the message that you usually have here from all the professionals like this is integration, interaction. We need to talk with each other so that we guarantee that we understand the point of view of the other technology, see other aspects. And when we work together, we can do a good design that will be safe and also be easy to certify, and you have less problems in service, right?
Yeah, exactly. That's it.
Okay, so Israel, I would like to thank you very much for being here with us. And I'm sure that you'll be here more times talking about maintenance and safety in other opportunities. I'm counting on you with that already.
Thank you very much, Clarissa. Thanks for the opportunity. Thank you.
Thank you very much for watching us. And if you like our video, give us a thumbs up. And you can know more about maintenance and safety in the playlist that you have here. And other interesting videos that you appear here. And subscribe to our channel, and see you in the next video.